All right, how many of you used elimination to do this? How about substitution? Anybody? Okay, how many of you graphed it? Okay, nobody graphed it. All right, elimination is probably the easiest. I'll copy it over here. Here's what you could do. What would you multiply the bottom one by? Yeah, that's -2. So this becomes -2y minus 6x equals -4. Don't forget to do both sides. And then we're going to combine these two, right? Add them up. So this plus this is 0. That plus that is 0. 3 plus -4 is not 0. So now it says 0 equals -1. If it makes no sense, then there is no solution. How many solutions then? 0. You could also graph it. What do you think the graphs would look like if you're guessing? They'd be parallel. So like this one here, y equals 2 minus 3x. 2 and then -3. So down 3 over 1. Down 3 over 1. Down 3 over 1. The other way. Up 3, left 1. There's our line. Up 3, left 1. Okay, there's one of the lines. This one, 2y equals 3 minus 6x. And then divide everything by 2. So this would be at 1.5. That'd be kind of funky to graph, right? 1.5. And then go down 6 over 2, which is the same thing as down 3. 1, 2, 3 over 1, right? And then you should be able to tell right there, because they are parallel, they have the same slope, right? Or I should say it the other way. Because they have the same slope, they're parallel. But their y-intercepts are different, right? This one had y-intercept of 1.5. This one had a y-intercept of 2. I didn't graph that right anyway. That should be up here. There you go. My fault. Very close to each other, but not quite. All right, so which brings me to this. So if you graph the lines, the point where they cross is where the solution is, right? We know this from the previous solution or the previous tests that we've done. These are the important ones today. If the lines are parallel, it's no solution. If it's identical, then there are infinite solutions, right? We've also seen that. This is new stuff for us this year. Two lines, and you've had it before. Two lines are parallel if they have the same slope. But I really want to focus on this one today because it might be different. If the product of their slopes is -1. All right, so as an example here, what would that look like? Two lines that have a product of -1. Let's say one line has a slope of -2. Let's say another line has that slope. What would you get if you multiplied them? You'd get -1, right? -2 times a half is -1. This would be an example where two lines are perpendicular. What does perpendicular mean? They intersect at a certain kind of angle. What's the angle? Right angle. So it has to be 90 degrees, right? So, for example, if one of them had a slope of 3, what would the perpendicular line to that have a slope of? In order for them to be perpendicular, they have to multiply to equal -1. What would the slope have to be? Another way that people teach this is they say flip, right? Opposite reciprocal. You ever seen that? Okay, so flip it and make it negative. So this is 3 over 1, right? Let's flip it and make it negative. Okay, the term is opposite for positive to negative, and then reciprocal means flip upside down. Okay. So these two terms are what we're going to focus on in the next couple problems we're going to do. Skip that one. Try number 2 right here. Give that a shot right now. It's got a couple minutes left. I'll go fast since we're running out of time. What's the slope right here on this line that's on our screen? Down 2 over 1, right? Down 2 over 1. So the slope is -2. We want to find the perpendicular one, so we got to flip it upside down and make it the opposite. This one has a slope of 1/2. Okay? There you go. We'll talk about this a little more tomorrow.